Waterways such as lakes, rivers, and oceans are essential to human life, and thus it is critical to monitor them. Many of our food sources, such as large crop fields and fish hatcheries, depend on water quality.
In 1968, 100 million tons of petroleum products, 2 to 4 million tons of active chemical waste, and 1 million tons of industrial heavy metals were dumped into the ocean.
These numbers only cover 1 year pollution from the United States and don't account for radioactive waste, trash from homes, and much more.
We're creating a solution that doesn't require government action, but can lead to higher water quality by empowering crowdsourced actions with affordable technology.
Shown here is our operational view. If you look at the bottom half of the diagram, you can see the various bodies of water we hope to place our sensors in. This data will be transferred to a collector, which can either be carried by a human being or by a mobile unit such as a drone. This data will then move to ground control, which will upload the data to a server protected by various security measures, and eventually this data will be visible on a user interface such as a website or an application.
This is our system diagram. On the bottom left is our sensor, which uses an ESP8266 microchip. It collects turbidity, temperature, and pH using sensors. An anchor prevents it from drifting away, and it is housed in a waterproof enclosure. It will last over 1 year since it is powered by a LiPo battery, which is charged by a solar panel. Every 30 minutes, it collects data. Once a week, it exits deep sleep for 15 minutes. If a collector is nearby, the data is transferred using MQTT Wi-Fi, which allows our sensors to be deployed anywhere. On the right, our collector uses a Raspberry Pi Zero and is manually charged. It is housed in a custom 3D printed enclosure. The user brings it back to ground control after a data collection to upload data. To ensure data is not tampered with, it is securely transferred by SSH. We will implement other data encryption methods as well. Data is displayed on a website built with Python Flask server and Plotly for visualization.
Here's our ESP8266 microchip that is taking in data from 3 sensors. It's sending the data over Wi-Fi to our Raspberry Pi collector. Here on the left, you can see the data our collector is saving, and on the right is data directly from the serial output of the sensor microchip.